It's the end of the second week of June 2025. We went from peering into the early universe with the first image from the SKA-Low to learning about the potential real-world ability of a cloaking device before learning about the hot side of the moon. Let's take you on a deep dive. The first image from the International Square Kilometer Array Observatory's telescope in Australia, SKA-Low, has been released, marking a significant milestone in its quest to reveal an unparalleled view of our universe. This first image from an early working version of the SKA-Low telescope, using just 1,000 of the planned 131,000 antennae, gives an exciting indication of the scientific revelations that will be possible with the world's most powerful radio observatory. SKA-Low is one of two telescopes under construction by the SKA Observatory, co-hosted in Australia, and SKA Mid in South Africa, on behalf of its member states and the global community. The image shows an area of sky of around 25 square degrees, equivalent to approximately 100 full moons. In it, we see around 85 of the brightest known galaxies in that region, all of which contain supermassive black holes.
So this is just the first glimpse, indeed, of what we're going to see with the full telescope when it's available. So with this first image, we're able to take just a quick first look at this part of the sky where we see can already see 85 galaxies shining in radio waves. Eventually, when we have the full telescope built, we're expecting to be able to see up to 600,000 galaxies in just the same piece of sky. So really, it's a first taste of what's to come.
It is very exciting. In the image, we're seeing about 25 square degrees of the sky. The analogy I used from the press conference, the press release earlier in the week, was that that's equivalent to 100 full moons, which sounds large, but it kind of isn't.
It's in a way, it's just a small piece of the full sky that we'll be able to observe with the telescope. But really, when it comes to the size of the universe that we're able to study, it's huge. So we have this is a very wide field telescope, which enables us to survey the universe very quickly. And one thing that we're looking forward to is utilizing the depth component of what we're seeing in that small piece of sky. So it's not just the dimensions that you see on the sky, but more the depth. And in fact, looking back in time. As we look deeper in the universe, we're looking back further in time. And this telescope is really designed to look back, right back to the beginning of the universe almost, the time when the first stars and galaxies were starting to light up, change the conditions of the universe around them. And that's the part of the universe and everything since that we're really aiming to study with this telescope.
When complete, the area of sky will reveal much more. Scientists calculate the telescope will be sensitive enough to eventually show more than 600,000 galaxies in the same frame. A pioneering study has delivered transformative insights into the behaviour of colloidal particles under microgravity. Conducted aboard the International Space Station, this research has not only been prominently featured in NASA's 2024 annual highlights of results from the International Space Station science, but also promises to reshape future material technologies, including revolutionary optical devices and even the elusive cloaking devices reminiscent of Star Trek and science fiction. Colloidal clusters are aggregates of nano and micrometer-sized particles suspended in a fluid, and they play a pivotal role in various industrial and scientific applications. In a specialised experiment setup, the research team mixed oppositely charged colloidal particles in an aqueous solution, allowing them to cluster in the absence of gravity, providing an opportunity to understand the fundamental science of association. Optical microscopy revealed that even minimal gravitational effects post-return can significantly influence the formation of colloidal structures, underscoring the value of space-based research. Principal Instrument Scientist Associate Professor Jitendra Matta at ANSO's Australian Centre for Neutron Scattering said that the significance of these experiments extends well beyond fundamental science. Colloidal clusters have been shown to scatter light in the visible to near-infrared spectrum, making them highly promising for applications in photonics, optical communications, and laser technologies. The inclusion of this work in NASA's prestigious publication is a testament to its far-reaching impact and promise. Increasing greenhouse gases in our atmosphere may reduce the total number of satellites that can safely orbit the planet, say UK researchers who used computer simulations of the atmosphere to work out the number of satellites that could be maintained sustainably in Earth's orbit by the year 2100 under different emissions scenarios. They say that under the highest emission scenario, low Earth orbit will be unattainable for up to 2 in 3 of our current satellites, or around 25 to 40 million satellites. This is because Earth's upper atmosphere will cool and shrink in response to greenhouse gas increases, reducing the volume of space available to host orbiting satellites. Using the greenhouse gas concentration in the year 2000 as a baseline, William Parker and colleagues found that the maximum number of satellites that can be sustainably managed in low Earth orbit will be 50 to 66% less by 2100, dependent on solar activity under the highest emission shared socio-economic pathway scenario. Although active deorbiting technologies are being considered to reduce the risk of collisions, the authors suggest that mitigating greenhouse gas emissions is not only important for Earth's climate, but also for preserving our access to and use of outer space. An international study featuring scientists from Curtin University's School of Earth and Planetary Sciences and Space Science and Technology Centre offers new insights into the Moon's history and provides a better understanding of what lies beneath its cratered surface. Researchers from Curtin University, Nanjing University and the Australian National University analysed tiny green glass beads collected by Chang'e 5, who were found to have unusually high levels of magnesium, which Professor Alexander Nimchin from the School of Earth and Planetary Sciences said was evidence of a potentially deeper origin. These high magnesium glass beads may have formed when an asteroid smashed into rocks that originated from the mantle deep within the Moon, Professor Nemchin said. Co-author Professor Tim Johnson, also from Curtin's School of Earth and Planetary Sciences, said the chemistry of the beads was unlike that of lunar surface rocks sampled previously. Professor Johnson said the rocks may have been brought up from the Moon's mantle by a massive impact. The Moon's near side, the side facing Earth, is dark coloured and dominated by ancient lava flows, whereas the far side is more rugged, and NASA researchers now suggest it's due to a wonky lunar interior. Using data from twin spacecraft named Ebb and Flow, they found a 2 to 3% difference in the Moon's mantle ability to deform on each side. Ryan Park and colleagues analysed data from the NASA Grail mission to map the Moon's gravitational response to its orbit around Earth, which can offer insights into the satellite's internal structure. Park and colleagues then modelled the Moon's structure and determined that the 2 to 3% figures can be explained by a difference in mantle temperature of 100 to 200 Kelvin between the two hemispheres, in which the near side mantle is warmer than the far side. They hypothesised that this thermal difference could be sustained by radioactive decay of thorium and titanium within the Moon's near side, which could be a remnant of the volcanic activity that formed the near side surface 3 to 4 billion years ago. The authors note that the methods used to probe the Moon's interior could be used to measure differences in the structure of other planetary bodies, such as Mars, Enceladus, and Ganymede, specifically because they do not rely on a spacecraft landing on the surface. Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week, and the occasional science fiction podcast. Like, follow, and subscribe for more. Membership available to help us do more, thetrek.zone/support. This is Trekzone's Talkin' Science.